All right, welcome back. Now we're going to do another example where it's now subtraction. And so again, the same rules apply. We need to get a common denominator. And the first step is going to be to factor out the denominators to see how we're going to get that least common divisor. Okay? Okay, so let's rewrite this. So this is going to be 3x plus 5 over, now this is going to factor, this is 3 and this is 2. They're both positive, so this is either going to be both negative or positive, but since this is positive, they're both positive. So, so this is going to be 3 times 1, right? Because 3 plus 1 is equal to 4. So this is going to be x plus 1 times x plus 3. Okay, now let's do the same thing on this side. So x minus 5, and then this is going to factor, but in this case here we've got a negative 3, so it's going to be 2 different signs, and the larger sign is positive. And again, this is going to be negative 3 times 1, positive 3 times 1. So this is going to be x minus 1 times x plus 3. Okay, now, we want to get a common denominator here, so we want all the factors to be the same. So here we've got an x plus 3, an x minus 1, we've got an x plus 3, and an x plus 1. So they both have an x plus 3, but this side is missing an x plus 1, this side is missing an x minus 1. If we multiply the top and the bottom by the factor respectively, we'll get the same thing. So over here, I'm going to multiply by x plus 1 over x plus 1. And over on this side, I'm going to multiply the top and the bottom by x minus 1 over x minus 1. And so now, if I combine them, I get x minus 1 times 3x plus 5 over x minus 1, x plus 1, x plus 3 minus x minus 5 times x plus 1 all over x minus 1, x plus 3 times x plus 1. And now I've got two rational expressions with the same denominator. And so now I can add across the top and keep the bottom. So that means I'm going to end up with x minus 1 times 3x plus 5 minus x minus 5 times x plus 1 all over x minus 1, x plus 1, x plus 3. Okay, and so now if we can simplify that, that would be the next step, because we want to be able to simplify these expressions. Okay? So now let's do that, because we might get something that can factor out. So let's go back. So now we're here. Let's go back to the top. And let me copy this over. Okay, so let me, so this is going to be what? If we distribute this, this is going to give me 3x squared plus 5x minus 3x minus 5. And then minus, this is going to give me x squared plus x minus 5x minus 5. And I'm just going to leave the bottom factored. All right. Let me just double check, make sure I didn't make any mistakes. So this is 3x squared, 5x minus 3x minus 5, and then minus. Notice I put parentheses around this whole thing because I'm subtracting the whole thing. So don't want to just forget that. So that's x squared plus x minus 5x minus 5. Okay, so now let's continue and simplify this. Okay, so now I'm going to distribute the negative sign. So this is going to be negative. This is going to change to negative, positive, positive. Okay, so all I did was distribute the negative, the subtraction. I just used the distributive property. And so now what I'm going to do is I'm going to combine like terms. So I've got 3x squared minus x squared. So that's going to give me 2x squared. I got 5x minus 3x, which is 2x, minus another x, which is x, plus 5x, which gives me 6x, right? So I can do it this way too. So this plus 5 cancels, or actually not cancels. So this 5x and this 5x go together. So that gives me 10x. And then this minus 3x minus x gives me a minus 4x, which gives me a plus 6x. And then the minus 5 and the plus 5 cancel each other out. Okay, so that's what I get. And then all of this is over x minus 1, x plus 1, x plus 3. Now I can factor this further because I can take a 2x out. So that's going to be 2x times x plus 3. And I get x minus 1, x plus 1, x plus 3. And of course the x plus 3 on top cancels with the x plus 3 on the bottom. And so I end up with 2x over x plus 1, x minus 1. And that is the final answer. All right, see you next time.